Passive components in RF circuits: resistors, capacitors, temperature-compensated oscillators. Learn about passive components used in RF systems. RF systems are not fundamentally different from other types of electric circuits. The same laws of physics apply, and consequently, the basic components used in RF designs are also found in digital circuits and low-frequency analog circuits. Capacitors. An ideal capacitor would provide exactly the same functionality for a 1 Hz signal and a 1 GHz signal. But components are never ideal, and the non-idealities of a capacitor can be quite significant at high frequencies. C corresponds to the ideal capacitor that is buried among so many parasitic elements. We have non-infinite resistance between the plates, series resistance, series inductance, and parallel capacitance between the PCB pads and the ground plane. We're assuming surface mount components. More on this later. The most significant non-ideality when we're working with high-frequency signals is the inductance. We expect the impedance of a capacitor to endlessly decrease as frequency increases, but the presence of the parasitic inductance causes the impedance to dip down at the self-resonant frequency and then begin to increase. Inductors. The following is an equivalent circuit for an inductor. An ideal inductor would provide impedance that steadily increases as frequency increases, but the parallel capacitor eventually dominates the response, and the result is impedance that decreases as frequency increases. So we can see that both capacitors and inductors must be chosen carefully when they will be used in RF circuits, especially RF circuits with frequencies well above 1 GHz. Crystals. As in other types of circuits, crystals are a fundamental means of generating a stable frequency reference. However, in digital and mixed signal design, it is often the case that crystal-based circuits actually do not require the precision that a crystal can provide, and consequently, it's easy to become careless with regard to crystal selection. An RF circuit, in contrast, may have strict frequency requirements, and this calls for not only initial frequency precision, but also frequency stability. The oscillation frequency of an ordinary crystal is sensitive to temperature variations. The resulting frequency instability creates problems for RF systems, especially systems that will be exposed to large variations in ambient temperature. Thus, a system may require a TCXO, a temperature-compensated crystal oscillator. These devices incorporate circuitry that compensates for the crystal's frequency variations. Balance. One component that is common in RF systems, but rare elsewhere, is the balun. The name comes from balance to unbalanced, a phrase which helps us to remember that baluns are used to convert differential signals to single-ended signals, or single-ended to differential. Baluns fall within the general category of transformers, as you can see from the circuit symbol. In lower frequency circuits, we often use amplifiers to convert between single-ended and differential, whereas in RF baluns are common. Why the difference? Well, the explanation is related to a fact that influences many RF design decisions. Simple passive components are often more practical than IC-based equivalents when you're dealing with very high frequencies. Antennas, resistors, etc. Antennas. An antenna is a passive component that is used to convert an RF electrical signal into electromagnetic radiation, EMR, or vice versa. With other components and conductors, we try to minimize the effects of EMR, and with antennas, we try to optimize the generation or reception of EMR with respect to the needs of the application. Even resistors can be troublesome at high frequencies because they have series inductance, parallel capacitance, and the typical capacitance associated with PCB pads. Resistors. And this brings up an important point. When you're working with high frequencies, parasitic circuit elements are everywhere. No matter how simple or ideal a resistive element is, it still needs to be packaged and soldered to a PCB, and the result is parasitics. The same applies to any other component. If it's packaged and soldered to the board, parasitic elements are present.